Dear students, welcome back. In the previous session, we have finished the elbow complex. Now, we are going to start the wrist and the hand complex. So, before starting this wrist complex and the hand complex, you have to understand the importance of the hand, which is a part of the upper limb. And this human hand is greater than or better than of all body parts except the brain. The human hand has been characterized as a symbol of power, an extension of intellect, and the seat of the will. Okay, the symbiotic relationship of the mind and hand is exemplified by the sociologist. That means this relationship of mind and hand being a typical example by the sociologist, claim that while the brain is responsible for the design of civilization and the hand is responsible for its formation, the hand cannot function without brain to control it. Likewise, the encapsulated brain, which is sitting in the cranial cavity, needs a tool of expression. That tool of expression is done by the hand. Okay, that means the thoughts which are arising in the brain, it has to be shown outside. That thing is shown by some of the movements of the hand. Hand is the only part in our body shows some symbols, isn't it? So that symbols represent the thoughts which are created in the encapsulated brain. That means, something, for example, a beautiful flower which is present in front of you, without talking and without giving any expression on your face, but you can or you can show the beautiful of the flower by showing some signs made by your hand, like super symbol like that. So that one is shown only with our hand, not with any parts of our body. Okay, so that means this hand becomes the tool for the expression which is created a thought inside the brain. Okay, so the entire upper limb is dependent to the hand. Okay, so that means, whatever we have studied in shoulder complex, elbow complex and all these functions of all this shoulder and elbow is finally used to enhance the function of the hand, isn't it? Yes. Any loss of function in the upper limb, regardless of the segment, any loss of the function in the upper limb, maybe loss in the shoulder joint, maybe loss in the elbow joint or any wrist, whatever joints, whatever the things related to the upper limb is injured or any loss of its function, which ultimately diminishes the function of the most of its distal joints, that is the joints present in the hand. Okay, so why this is happening? So if the proximal part of the upper limb is affected, but the distal parts are also affected, why? So this creates some scope of study to understand the finely balanced complexities of the normal upper limb and the hand. Okay, so now this is about a small introduction about the importance of the hand here. Now coming to the wrist complex. So in this chapter we are going to study the wrist complex separately and the hand complex, and both these complexes are intimately connected here. Okay, so we are going to study the wrist complex separately and hand complex separately to understand the functions of the hand further. Okay, now in the wrist complex, normally the wrist complex consists of two compound joints. One is the radiocarpal joint. So this is the radiocarpal joint, and the other joint is the midcarpal joints. So like other joint is the midcarpal joints. These two joints referred collectively called as a wrist complex. Normally we can say individually this is the radiocarpal joint, commonly called as wrist joint. So this is the radiocarpal joint. We can see in this radiograph also, and the midcarpal joint here, this forms the midcarpal joint. Okay, normally this joints you can see in this pic also very clearly. So this becomes the proximal part and this becomes the distal part. Proximally it forms the radiocarpal joint. So this is the radius is articulating with the proximal row of the carpals, forming the radiocarpal joint. It is commonly called as wrist joint. And this proximal row of carpals and the distal row of the carpals forms the midcarpal joint. Okay, and in between the carpals also you will have some joints that is called as intercarpal joints. But in the wrist complex, the wrist joint and the midcarpal joint both collectively called as wrist complex. Okay, yes. Now we are going to see this importance of this wrist complex. Each joint proximal to the wrist complex, whatever the joint which is present proximal to the wrist complex, that means proximal to the wrist complex means you'll get the radioulnar joints, you'll get the elbow joints, okay, elbow joint, and the shoulder complex. So whatever the joints which is present proximal to the wrist complex serves to broaden the placement of the hand, in space. That means the hand should be reached to any other part which is far away from the body, which is done by these proximal joints. Okay, yes. So these proximal joints serves to broaden the placement of the hand in space and to increase the degrees of freedom available to the hand. So, and it is also increase the degree of freedom available to the hand. So what does the shoulder do? What does the elbow do? And what does the forearm do? Okay, so the shoulder serves as a dynamic base of support. The shoulders acts as dynamic base of support, whereas the elbow allows the hand to approach or extend away from the body, and the forearm adjusts the approach of hand to an object. Okay, so these are all the function of the proximal joints which is present above the wrist complex. Okay, the corpus, unlike the more proximal joints, serves placement of the hand in space to only a minor degree. So that means the wrist joint, this wrist complex, we can call it as, this wrist complex only helps to the hand in space for a minor degree. So the major contribution of the wrist complex, so this main function of this wrist complex is to control length tension relationships. It mainly controls the length tension relationships in the multi-articular hand muscles and to allow fine adjustment of grip. So this is the main function of the wrist here. So here the wrist will have a minor function to keep the hand in space. So those things are done by the proximal joint. Then there is no such kind of need for this wrist complex. So then what is the major function here is the wrist complex control the length tension relationships in the multi-articular hand muscles and allow fine adjustment of grip. Okay, and the wrist muscles appear to be designed for balance and control rather than for maximizing the torque production. That means it is the muscles designed here is to balance and control. The adjustments in the length tension relationship of the extrinsic hand muscles that occur at the wrist cannot be replaced by any compensatory movements of the shoulder, elbow or forearm. So normally if anything happens in the shoulder joint, so there is a compensatory movement which is taking place in another joint. For example, in the case of elbow joint, it has to, but if the elbow joint, that means during pronation, that is elbow complex, during pronation, what will happen if the pronation is affected? So for this compensation, the shoulder is going to abduct and internally rotate it to compensate the pronation to reach an object. So such kind of things are not happened in the wrist. So because of that compensatory movements of shoulder and elbow of forearm are not seen in the case of any loss in this wrist. So the wrist has been called the most complex joint in the body from both an anatomical as well as the physiological view. And the complexity and the variability of the interarticular and the intra-articular relationship within the wrist complex has received a large amount of attention in 2 points. The first one is the structure and biomechanics of wrist as well as of hand vary tremendously from person to person. And the second one is the wrist joint, even subtle variations can produce differences in the way a given function occurs. Okay, so these are the 2 points should be considered because of this complexity and the variability of this interarticular and intra-articular relationships within the wrist complex. Okay, now we will see what are the things seen in the wrist complex. So these are all just an introduction. We are going to see this explanation of this wrist complex, like structure of the wrist complex and functions of the wrist complex in the later sessions. So the wrist complex as a whole is considered as biaxial with motions of flexion and extensions, with the motions of flexions and extension. So for example, this is the arm and this is the hand. So this one is the flexion and extension, and if you see in this anatomical view, and it is also having an abduction and adduction. Okay, that is ulnar deviation and the radial deviation. So the wrist complex as a whole considered as a biaxial with movements flexion and extension around a coronal axis. That means coronal axis means in the sagittal plane you will get the flexion and extension, and ulnar deviation and radial deviation around an AP axis. Some of the investigators argue that some degree of pronation and supination also found, especially at the radiocarpal joint. So we are not considered that pronation and supination. The ranges of motion of the entire complex are variable and reflect the differences in carpal kinematics that arise from such factors as ligamentous laxity, the shape of articular surfaces, and constraining effects of the muscles. Okay, that means the range of motion is going to be varied according to the attachments of this ligaments, and also their laxity and the shape of the articular surfaces and the constraining effects of the muscles. So normally the normal ranges are 65 degrees to 85 degrees of flexion, 60 degrees to 85 degrees of extension, 15 degrees to 21 degrees of radial deviation, and 20 to 45 degrees of ulnar deviation is seen. Okay, and the ranges are contributed in various proportions. So whatever the ranges I have mentioned here, so these are contributed in various proportions by the compound radiocarpal joint as well as the midcarpal joint. That means, so for example, from 65 to 85 degrees of flexion, some degree of flexion is take over by this radiocarpal and then the midcarpal joint, like this. Okay, the ranges are contributed in various proportions by this compound radiocarpal and midcarpal joints. Some investigators like Guilford and colleagues proposed that the two joint rather than single joint system of wrist complex permit, so such kind of complex permits large range of motions with less exposed articular surfaces and tighter joint capsules. So that means such kind of wrist complex having two joints permitting large range of motion with less exposed articular surfaces and tighter capsules, and this joint had less tendency for structural pinches at extremes of ranges. We have seen in the shoulder joint, so when you reach the maximum abduction, so some of the structures are going to pinching in between the subacromial space like bursa and the supraspinatus tendons. So those are the structures which are going to pinch at the extreme range of motions. But in this kind of joint design, this wrist complex had less tendency for structural pinch at extremes of ranges, and it is allowed for flatter multi-joint surfaces that are more capable of withstanding imposed pressures. So because of this flattened multi-joint surfaces are more capable of withstanding imposed pressures. So these are all about the main functions of the wrist complex. Now we are going to see in the later sessions what is the structure of radiocarpal joint and its function, and also the midcarpal joint and its function, and how these two joints help in the increased range of motions. We are going to study in the next session. And you should also understand the hand complex also here. I am going to give some introduction regarding the hand complex. That means this hand complex is definitely a complex design, because the hand consists of 5 digits. So these are the 5 digits. That means it includes 4 fingers and 1 thumb. Okay, so each digit has a carpo-metacarpal joint. So this one is the carpo-metacarpal joint, and then metacarpophalangeal joints, and then the interphalangeal joints, that is IP joints. So for the 4 fingers you'll have 2 IP joints. For the thumb it is having only 1 IP joints. Okay, so therefore there are 19 bones distal to the carpals. So distal to the carpals it is having 19 bones. Okay, and then it is forming 19 joints to make up this hand complex. Okay, so in this hand complex we are going to study these structures separately and their functions also, but there are some structural similarities for these 4 fingers, and there is some difference in the joints of the thumb function. Okay, so for that reason we have to examine the thumb separately with that of the remaining 4 fingers. Okay, and what are the muscles which are going to help in the gripping function, and also the flexion of MCPs and ICPs and extensions like that. And also we are going to study this extensor mechanisms. We have to understand here this extensor mechanisms, and the lumbrical muscles and the intrinsic muscles, the intra-share muscles. We are going to study the functions of all these small muscles to understand the function of the hand complex. The main function of the hand is the gripping function. So we are having different kinds of grips. So those grips we are going to study in detail in this hand complex. So in the next session we are going to study the structural components of the wrist complex. Thank you.